Hello, welcome to another tutorial from Smart Learning with Tati. And in this tutorial, we'll be looking at the concept of differentiation from first principle. We have a definition of differentiation here that says differentiation is the process of finding the rate at which one quantity changes with respect to another. Now, what does this mean? Let's see if we can unravel this definition using a simple illustration. What we have here is a distance time graph that shows how much distance was covered by a car moving in uniform motion in a particular amount of time. The y-axis shows the distance covered and the x-axis shows the time it took for the car to cover the distance. Now, if you recall from the tutorials on function, we know that x is the input values while y is the output values. Therefore, we can express this as a linear function where y is a function of x. So what is this graph trying to show us? Now, as you can see from the graph, at 0 seconds the car hasn't moved, it has not covered any distance because it is simply at rest. But after 5 seconds we see that the car has covered 50 meters. So we can do it like this. Also, we see that after 20 seconds the car has covered a distance of how many meters? 200 meters. So something like this, and so on and so forth. Now, what if you were asked to find the speed at which this car is moving from, let's say, this point here, let's call it A, to this point here, let's call this B. So we want to know the speed of the car from point A to point B. Now remember, the formula of speed is what? Distance over time. So speed is equal to distance over time. So we're going to start by calculating the distance covered from point A to point B. And to do this, we just simply need to subtract the value of A on the y-axis, which is this 50 meters, from the value of B on the y-axis, which is what? 150 meters. So we have to use two values here, 50 meters and 150 meters, and this will give us our distance. So distance will be equal to 150 meters minus 50 meters, which is of course 100 meters. Therefore, we can say that the distance covered from point A to point B is how many meters? 100 meters. We can also call the distance from point A to point B the change in distance from point A to point B. That is, how much has changed in distance from point A to point B. And we know that it changed by 100 meters. Now, I want you to keep this in mind because it will help us in understanding the definition of differentiation. Now, we are not yet done in calculating the speed. We also need to find the time taken in moving from point A to point B. And to do this, we just apply what we've done in finding distance. So what do? We simply subtract the value of A on the x-axis, which is 5, from the value of B this time around on the x-axis, which is what? 15 seconds. So we can say that time is equal to 15 seconds minus 5 seconds, which is equal to what? 10 seconds. Therefore, we can say that the time spent going from point A to point B is 10 seconds. And like we already know, we can also call this the change in time from point A to point B. That means how much time has changed from A to B. And we know that it changed by how many seconds? 10 seconds. Now, to calculate the speed, we can simply take the results we got. So speed is equal to the change in distance from point A to point B, which is what? 100 meters, all over the result we got in the change in time from point A to point B, which is 10 seconds. And if we divide this, we should have 10 meters per second. So this is the speed of the car from point A to point B. So we can as well say that the speed is equal to change in distance all over change in time, right? Now there's a special symbol we use to represent the change in any quantity, and that is the delta symbol. It's shaped like a small triangle. So, and we use it in calculus to represent the change in any quantity. So therefore we can write speed, if we apply that quantity now, to be equals to change in distance all over change in time, which is equal to 10 meters per second. Since speed is distance over time, where y represents distance, so let's go back to our graph. I'll show you something here. So remember, y represents distance here and x represents what? Time. We can use the formula of the slope or gradient of a straight line given 2 points to find the speed. So a shorter way is just simply to find the slope of this straight line here. And to do this, there's a formula we have to use. Now we use the letter m to represent slope. And the formula for slope is giving us y2 minus y1 all over x2 minus x1. So this is the formula for calculating the slope or gradient of any straight line. So let's determine what our y2 and y1 is. Going back to the graph. So y2 is the value of point B on the y-axis. So this is y2. And y1 is the value of point A on the y-axis, which is here. y1 is 50 meters, y2 is 150 meters. And then we come down. The value of point B on the x-axis becomes our x2, while the value of point A on the x-axis becomes our x1. So if we impute these values in our formula for the gradient of a straight line, should have y2 as 150 meters minus 50 meters all over 15 seconds minus 5 seconds. And we still get the same thing as 100 meters all over 10 seconds, which is equal to what? 10 meters per second. So we can say that the speed of the car from point A to point B is equal to the slope m of the straight line from A to B, which is giving us y2 minus y1 over x2 minus x1. Now this y2 minus y1 we have here, y2 minus y1, we can call this the change in y, which can be written as delta y. Remember that delta. And also x2 minus x1 can also be called the change in x, which can be written as what? Delta x. Therefore, we can write the slope m as change in y all over change in x, which we know is equal to what? 10 meters per second. Now this brief illustration we just did here explains the whole concept of differentiation as finding the rate at which one quantity changes with respect to another quantity. And in this case, we just found speed, which is the rate at which distance changes with respect to time. Therefore, we can conclude that to find the speed of a car moving in uniform motion represented by the function y equals to f of x, we have to differentiate distance with respect to time, or better still, differentiate y with respect to x. So we can express this entire statement mathematically. So if we want to find the rate of change of this function, we use a symbol like this, that is f prime of x. That's a symbol for differentiation or derivative. We're going to use that more often when we begin to work on differentiation problems. So for now, just take note of this symbol here. Will be equal to change in y over change in x. So that's the basic idea behind differentiation. I'm sure that by now the concept of differentiation is clear. In the next segment of this tutorial on calculus, we'll get into more details on the concept of differentiation from first principles. Until then, thank you for watching, and I hope to see you in the next one.